Earth's 4 layers. What's inside our planet? Have you ever wondered what's beneath your feet? From earthquakes to volcanoes, the Earth's layers play a huge role in shaping our planet. Today, we're breaking down the 4 main layers of the Earth in a simple and exciting way. Stay until the end for a fun fact that will blow your mind. Let's get started. First up, we have the crust, the outermost layer where we live. It's like the skin of an apple, super thin compared to the other layers. Now, when I say thin, I mean like really thin. If the Earth were the size of a basketball, the crust would be thinner than a piece of paper. Can you believe that? We're living on a thin sheet of rock, floating on a sea of molten rock. And you thought surfing was cool. The crust is made of solid rock and is divided into 2 types. Continental crust, the landlubber, is thicker and found under, well, land. And then there's oceanic crust, the thinner, denser type found under the oceans. But hold on to your hats, because here's where it gets interesting. The Earth's crust isn't just sitting still, it's constantly moving. These massive chunks of rock, called tectonic plates, are always bumping and grinding against each other. This movement causes earthquakes and even forms mountains over millions of years. It's like a slow-motion demolition derby down there. But instead of cars, it's giant pieces of the Earth's crust. And speaking of what's down there, let's dig a little deeper, shall we? Quick transition sound effect. Next, we have the mantle, the thickest layer of the Earth. It makes up about 84% of the planet's volume. That's like taking up most of the space in a giant gumball machine. The mantle is made of hot, semi-solid rock that slowly moves over time. You know how honey flows, but it's thicker than water? That's kind of what the mantle is like. It's this viscous, flowing rock. But don't worry, it moves way slower than honey. This movement is called convection currents, and it's what causes earthquakes, volcanoes, and plate tectonics. Remember those moving plates we talked about? Well, the mantle is the driving force behind all that action. The heat from the Earth's core causes the mantle to flow in these giant circular patterns, and that drags the plates along with it. Fun fact, the mantle's temperature can reach up to 4,500 degrees Fahrenheit, or 2,500 degrees Celsius. That's hotter than lava from a volcano. It's like a giant lava lamp down there, but instead of blobs of wax, it's molten rock. And speaking of hot stuff, let's head even deeper into the Earth, where things get really toasty. Quick transition sound effect. Chapter 3. The outer core. Earth's liquid metal layer. Now things get really hot. The outer core is made of liquid iron and nickel. This layer is so hot that the metals have completely melted. The outer core is super important because it creates Earth's magnetic field. That's what protects us from harmful space radiation and helps compasses work. Imagine a giant ball of molten metal, swirling and churning deep beneath our feet. That's the outer core. And this liquid metal isn't just sitting there looking pretty, it's constantly moving, and that movement generates electricity. And what happens when you have electricity flowing around a giant ball of metal? You get a magnetic field. This magnetic field acts like a giant shield, protecting us from harmful radiation from the sun. It's like Earth's own personal force field. And without it, life on Earth wouldn't be possible. So next time you use a compass, remember to thank the outer core for keeping you on track. Quick transition sound effect. Chapter 4. The inner core. The hottest layer. Finally, we reach the inner core, the deepest part of our planet. Even though it's the hottest layer, over 9,000 degrees Fahrenheit or 5,000 degrees Celsius, it's actually solid because of the intense pressure. Made mostly of iron and nickel, the inner core is about the size of the moon. Did you know? Scientists believe the inner core might be growing over time. As it cools, more of the outer core turns solid. We're talking serious heat here, folks. The inner core is hotter than the surface of the sun. But even though it's incredibly hot, it's not a liquid. The intense pressure at the center of the Earth is so great that it forces the iron and nickel atoms to pack together tightly, forming a solid. It's like trying to squeeze a snowball in your hand. The harder you squeeze, the more solid the snowball becomes. And the pressure at the center of the Earth is way more intense than your hand. So there you have it, the inner core, a giant ball of solid iron and nickel, hotter than the sun, and constantly growing. Quick transition sound effect. That's a wrap on Earth's layers. Let's quickly review what we learned today. Crust, the thin, solid outer layer where we live. Mantle, the thickest layer with moving rock. Outer core liquid metal that creates Earth's magnetic field. Inner core, a super hot solid iron-nickel center. You just learned everything you need to know about Earth's 4 main layers. Ready for more? Comment below what GED topic you want next. Like and subscribe for more easy science lessons. And don't forget to turn on notifications so you never miss a video.